Our lesson for today is illustrating a geometric sequence and differentiating a geometric sequence from an arithmetic sequence. Now let's have first our math storytelling. Anna and Pepe are putting fresh baked pandesal on the plate. They put 1 pandesal on the first plate, 3 pandesals on the second plate, 9 pandesals on the third plate, 27 pandesals on the fourth plate. Now, if the pattern continues, how many pandesals will be on the fifth plate? Okay, so it's finding the pattern. So as you can see, the sequence are 1, 3, 9, 27, and blank. So the plate represents the blank. So if we are going to find the pattern, we are going to consider the 4 fundamental operations. If not addition, say 1, if we are going to add 2 to 1, so that is 3, and then 3 plus 2 is not 9 but 5, so meaning it's not addition. Now for subtraction, of course, it's not possible, as well as in division, since this is increasing. Now, so therefore it's multiplication. If we're going to multiply it by 3, so it will be 1 times 3 is 3, 3 times 3 is 9, and then 9 times 3 is 27, 27 times 3 therefore is 81. So the pattern is times 3. Now let's have the next. We have, what is the pattern? 2, 4, 8, 16, 32. So if we're going to analyze, so this is 2 times 2, which is 4, times 2, which is 8, times 2 is 16, times 2 is 32. So therefore, the pattern is times 2. Next, how about this one? What is the pattern? 1, negative 1, 1, negative 1. If we are going to analyze, if we multiply it by negative 1, so this will be negative 1 times negative 1 again, so it will be negative times negative is positive, so that is positive 1 times negative 1 again, so this is negative 1. So therefore, the pattern is times negative 1. Next, what is the pattern? 1/2, 1/4, 1/8, 1/16. So we have, if we are going to multiply it by 1/2, 1 times 1 is 1, and then 2 times 2 is 4, so that is 1/4. Multiply it again by 1/2, so we have 1 times 1 is 1, and then 4 times 2 is 8, which is 1/8, times 1/2 again, so it will be 1/16. So therefore, the pattern is times 1/2. Now, as you can see, those are examples of our lesson for today, which is a geometric sequence. And you will notice that the operation that is included is multiplication. So the one that you multiplied to the preceding term is called the common ratio. Now let's have first the session objectives on page 6 of your module. So the session objectives includes, first, define and illustrate geometric sequence. Differentiate a geometric sequence from an arithmetic sequence. Now, on page 10 of your modules, you will see the difference between geometric and arithmetic sequence. So we have, for the meaning or for the definition, it is a sequence in which each successive term is obtained from the preceding term by adding it by a constant term. So that is our previous lesson, which is arithmetic sequence. While on the other hand, for geometric, you can highlight the term multiplying. Okay, it is a sequence in which each successive term is obtained from the preceding term by multiplying it by a constant number. So again, for the definition or meaning, the difference is here in arithmetic sequence, it's addition, and for geometric sequence, it's multiplication. Now, for the constant number, in arithmetic sequence, we called the constant addends as common difference, represented by small letter d. While in geometric sequence, we called it common ratio, represented by r, the one that we multiplied repeatedly to the preceding term to get the next term. Next, for operations involved, in arithmetic sequence, it's addition, which we use to find the next term. While in geometric sequence, we used multiplication to find the next term. Now, there is a special function of subtraction here. In arithmetic sequence, we can find the common difference using subtraction. While in a geometric sequence, we can find the common ratio by division. And then, of course, for variation of terms, in geometric sequence, this is an exponential, while in arithmetic sequence, this is linear. Next, now let's have an activity on page 11. Let us determine whether the following sequence is geometric or not geometric. Remember, when you say geometric sequence, it has a common ratio, a fixed number, wherein if we multiplied it with that fixed number, we can get the next terms or the succeeding terms. Let's have item number 1. We have 1, 8, 15, 22. If we're going to analyze, there is no fixed or constant number that we can multiply to 1 or 8, 15 to get the next term. So, meaning, item number 1 is not geometric. So, there is no common ratio. Next, for item number 2, we have 2, 10, 50, and 250. So, to get the common ratio, we can divide 2 divided by 2, 10 rather divided by 2 is 5. 50 divided by 10 is 5. 250 divided by 50 is 5. So meaning that 5 is the what we call common ratio. And since there is a common ratio r equals 5, therefore item number 2 is geometric. Next, item number 3, 2.5. Think of a number wherein if you are going to multiply it by 2.5, the result is negative 10. So that number is negative 4. 2.5 times negative 4 is negative 10. Negative 10 times negative 4 is positive 40. Positive 40 times negative 4 is negative 160. So therefore, there is a common ratio of negative 4. So therefore, this is geometric. Item number 4, 90 becomes 30. 30 becomes 10. 10 becomes 10 over 3. So decreasing. Meaning, there is a fraction that you are going to multiply. So that is 90 multiplied by 1/3. Okay, what is 1/3 of 90? So that is 30. 30 multiplied it by 1/3. What is 1/3 of 30? That is 10. And then 10 times 1/3, that is 10 over 3. So the fixed or the common ratio here is 1/3. So therefore, this is a geometric sequence. And then for item number 5, we have negative 1.5, 0, 1.5, and 3. So there's no common ratio.